Hi students, in this video we will cover the solutions of page number 6, 10, 13 of science chapter number 1 chemical reactions and equations. First we will discuss the solutions of page number 6. First question is, why should a magnesium ribbon be cleaned before burning in air? Magnesium is highly reactive with oxygen. Okay, the reaction we can represent like 2 Mg plus O2 gives 2 MgO. Okay, when magnesium it is in contact with air, magnesium will react with the oxygen present in the air and it forms a coating of magnesium oxide MgO. Okay, so if the magnesium we are using for any other desired reactions, it will not be the pure magnesium. One coating will be there for the magnesium ribbon. So first we should clean that coating. After that only we will use the magnesium. So that is the reason magnesium ribbon should be cleaned before burning in air. Question number 2. Write the balanced equation for the following chemical reactions. These are the chemical reactions we should balance. We will discuss one by one. First one is hydrogen plus chlorine gives hydrogen chloride. So here I am making two columns for number of atoms in reactants and number of atoms in products. First we will write the chemical equation for this. This is just a statement, so we should make it as hydrogen plus chlorine gives hydrogen chloride. Okay, now we can write the atoms here, hydrogen and chlorine. Here also the same only, it will be coming hydrogen and chlorine. Hydrogen it's 2 here, chlorine it's 2. In the product side, hydrogen it's 1, chlorine it's 1. Okay, so this is not balanced because the number of atoms in the reactant side and product side it's not equal. So if I keep a 2 here, the hydrogen and chlorine it's becoming 2. This 2 is common for both hydrogen and chlorine. So hydrogen it's 2 now, chlorine it's 2 now. Okay, previously it was 2 only here. So the equation it is balanced. Next question. Barium chloride plus aluminium sulfate gives barium sulfate plus aluminium chloride. So first we will write the chemical equation for this. Barium chloride we can represent like BaCl2 plus aluminium sulfate is Al2SO4 thrice. Okay, the chemical formula always it should be correct, otherwise the balancing will be wrong only. Al2SO4 thrice gives barium sulfate is BaSO4 plus aluminium chloride is AlCl3. Okay, now we can balance. Before that we will write the atoms here. Barium, chlorine, aluminium, sulfur, oxygen. The same order we can write here also. Barium, chlorine, aluminium, sulfur, oxygen. Now count the atoms. Barium it's 1, chlorine it's 2, aluminium it's 2, sulfur it's 3. This 3 is common for both sulfur and oxygen. Sulfur it's 3, oxygen it is 4 into 3, 12. Barium it's 1, chlorine it's 3, aluminium it's 1, sulfur it's 1, oxygen it's 4. Okay, so the chlorine, aluminium, sulfur, oxygen all are not balanced. Okay, so first I am choosing chlorine to get balance. Anything you can choose. Here I am choosing chlorine to get balance first. Okay, so here it's 2, here it's 3. Okay, so if I keep a 3 here, chlorine will be 3 into 2, it's 6. The same way if I keep a 2 here, the chlorine it's 2 into 3, 6. Chlorine it's balanced. Now what are the changes for barium and aluminium? Okay, I kept a 3 here. So what happened to the barium? It is 1 and here it is 3. So I can keep a 3 here to balance the barium. So the barium, it's balanced. Then what about the aluminium? It's 2Al here. Here Al2. So the aluminium also, it's balanced. Then what about the sulfur and oxygen? Sulfur, it is 3 here, right? Previously it was 3 only. So sulfur also got balanced. Then what about the oxygen? Oxygen, previously it was 12 and here 3 into 4. Okay. 3 into 4, it is 12. So this equation got balanced. 3, 6, 2, 3, 12. 3, 6, 2, 3, 12. Next question. Sodium plus water gives sodium hydroxide plus hydrogen. Very simple equation. Sodium, it's Na. Water, it is H2O. Gives sodium hydroxide is NaOH plus hydrogen, that is H2. Okay. Now we can write the atoms here. Sodium, hydrogen, oxygen. Sodium, hydrogen, oxygen. Sodium, it's 1. Hydrogen, it's 2. Oxygen, it's 1. Sodium, it's 1. Hydrogen, here and here we should add it together. 2 plus 1, it's 3. Oxygen, it's 1. So the hydrogen, it's not balanced. Okay. So hydrogen, here it is 2, here it is 3. So if I keep a 2 here, okay, hydrogen, what it became? It is 4 now. Okay. What about here? I kept a 2 here. Then 2 plus 2, hydrogen, it is 4. Okay. Then what happened to sodium? Sodium, it became 2 here. Okay. So here also we can keep a 2 to balance sodium. Then oxygen, it's 2. Here also it's 2. 2, 4, 2, 2, 4, 2. Equation, it is balanced. Question number 3. Write a balanced chemical equation with state symbols for the following reactions. Okay. These are the reactions we should balance and they are asking to mention the state symbols also. Physical states also we should mention with the balanced equation. So we will discuss one by one. First one, solutions of barium chloride and sodium sulfate in water react to give insoluble barium sulfate and the solution of sodium chloride. Okay, so we can write like solutions of barium chloride. Okay, BaCl2 as barium chloride, and solutions means we can represent the physical state as aqueous. Okay, then plus sodium sulfate is Na2SO4. Okay, in water. Okay, so again it is solution, so we can represent like aqueous, and it react to give insoluble barium sulfate. Insoluble means solid. Okay, plus solution of sodium chloride, NaCl. Okay, this reaction you can connect. Yes, this is an example for precipitation reaction or double displacement reaction. Here the barium sulfate is the precipitate. That's why they are mentioning it as insoluble. So it is a solid substance. And NaCl, that is soluble in water. So again it's aqueous. Now we can balance. Before that, first we will write the atoms here. Barium, chlorine, sodium, sulfur, oxygen. barium, chlorine, sodium, sulfur, oxygen. Okay, barium it's 1, chlorine it's 2, sodium it's 2, sulfur it's 1, oxygen it's 4. Barium it's 1, chlorine it's 1, sodium it's 1, sulfur it's 1, oxygen it's 4. So chlorine and sodium, it's not balanced. Okay, so first I will try to balance the chlorine. Chlorine it's 2 here, here it's 1. So I can keep a 2 here to balance chlorine. Now chlorine it is balanced. Then what happened to sodium? Sodium also it became 2 here. It was 2 here also. Okay. So now everything it got balanced. 1 1 4 1 1 4. Yes, the equation it got balanced. We can write like this. Next question. Sodium hydroxide solution reacts with hydrochloric acid solution to produce sodium chloride solution and water. So we can write the equation like sodium hydroxide, that is NaOH, and it's a solution in water, means physical state is aqueous. Okay, and it reacts with hydrochloric acid, again it's in solution, so again aqueous, to produce sodium chloride solution, NaCl, again it's aqueous, plus water. Water we know that it's a liquid. Okay, so this is the chemical equation. Now we should balance it. Sodium, oxygen, hydrogen, chlorine. Sodium, oxygen, hydrogen, chlorine. Sodium it's 1, oxygen it's 1, hydrogen here and here. So together it's 2. Chlorine it's 1. Sodium it's 1. Oxygen it's 1. Hydrogen it's 2. Chlorine it's 1. See, the equation it is already balanced. So we can write the chemical equation as it is. Now we will discuss solutions of page number 10. Question number 1. A solution of a substance X is used for whitewashing. Name the substance X and write its formula. Write the reaction of the substance X named in 1 above with water. Can you recall this formula? This is the calcium oxide solid substance. When we are soaking this calcium oxide in water, this calcium oxide and water reacted together to form calcium hydroxide, which we can use for whitewashing. So the calcium oxide, it is known as quicklime, and the product it forms with water, it is known as slaked lime. We can write the equation like calcium oxide is CaO and it is known as quicklime plus water to form calcium hydroxide, it is known as slaked lime. Okay, and this is the product which we can use for whitewashing. Question number 2. Why is the amount of gas collected in one of the test tubes in activity 1.7 double of the amount collected in the other? Name this gas. Your activity 1.7 is electrolysis of water. What do you mean by electrolysis of water? We can take some amount of water in a plastic mug or any other beaker, and two graphite rods we are dipping in water and we are connecting a battery to the ends of the graphite rod. The positive end connected to the anode of the rod and the negative end will be connected to the cathode of the rod. Okay, and after the electrolysis of water, water will get dissociated into hydrogen gas and oxygen gas. Hydrogen will be collected in the cathode and oxygen will be collected in the anode. And we can write the equation now. Electrolysis of water we can represent like 2H2O gives 2H2 plus O2. Okay, so after the dissociation of water, what it is forms hydrogen gas and oxygen gas. Calculate the amount of hydrogen gas and oxygen gas. It's here. Here two molecules of hydrogen and here one molecule of oxygen. So the amount of hydrogen gas is doubler than the amount of oxygen gas here. Now we can discuss the solutions of page number 13. Question number 1. Why does the color of copper sulfate solution change when the iron nail is dipped in it? Let us check this reaction. This is the copper sulfate solution. It is of blue color. When the iron nail is dipped in it, what the reaction it takes place? According to the reactivity series, iron it is more reactive than copper. So iron can displace copper from its salt solution. This reaction it is known as displacement reaction. We can write the displacement reaction of iron and copper sulfate solution. Iron Fe plus copper sulfate CuSO4 gives FeSO4 iron sulfate plus copper. Here copper sulfate it is of blue color, but after the displacement reaction it becomes iron sulfate and the color it changes from blue color to pale green color. Also for the iron nail also some color change it's there. Iron nail was of this color and after the reaction some coating of copper it forms on the iron nail and it becomes now reddish brown color. Question number 2. Give an example of a double displacement reaction other than the one given in activity 1.10. This is your activity 1.10. This is test tube containing solution of sodium sulfate. And this is a test tube containing solution of barium chloride. We are mixing these two compounds together and the reaction we can write like sodium sulfate. It is Na2SO4. And barium chloride it is BaCl2. The products are here NaCl plus BaSO4. So exchange of two ions are happening here. Na and Cl it combines to form NaCl and barium and sulfate ions it combine to form barium sulfate. So in this question they are asking we have to write some other reaction like this. Okay, so we can write like NaNO3 sodium nitrate plus silver chloride AgCl. The same reaction it happens. Na and Cl it combines to form NaCl and Ag and NO3 it combines to form AgNO3. We can represent the physical states also in this chemical equation. Question number 3. Identify the substances that are oxidized and the substances that are reduced in the following reactions. These are the given reactions and we have to identify which substance is getting oxidized and which substance it is getting reduced. So first we will write what is oxidation and reduction. Oxidation means gaining of oxygen. Reduction means losing of oxygen. And other important point, for checking the substance which is getting oxidized and which is getting reduced, always have a look for the reactant side, because oxidation and reduction, it's a reaction, it always happens in the reactant side. Here the product only it forms after the oxidation and reduction reactions. So here first we will check which is getting oxidized. Na, sodium plus oxygen combine to form sodium oxide, Na2O. Here clearly we can see sodium, it gains oxygen to form sodium oxide. So we can write Na is oxidized here. And in the second question, it is an example for redox reaction. It means both oxidation and reduction, it takes place here. First check H2. Hydrogen, it's not having any oxygen, but it has a tendency to gain oxygen and it forms as H2O. But the oxidation, it takes place here only. H2 hydrogen, it is oxidized here. And what about CuO? It had oxygen, but it loses its oxygen to form Cu. So reduction it happens here, because here only it loses its oxygen. CuO is reduced. I hope you understood the solutions of these questions. If you have any doubt regarding any of these questions, please comment in the comment box. Thank you for watching the video. Please like and share, and don't forget to subscribe the channel to get notification for new videos.